All right. So now that we came back from lunch, we're going to do the next problem. These next three are the exact same process, but I want us to use the RREF in the calculator. So we're going to use RREF. We got to write our augmented matrix, enter it in the calculator, press RREF, and then we'll solve and go from there.
So how do you know that they're like 3 by 4?
When I ask you to do Gauss-Jordan, or I ask you to do REF or RREF. So these are augmented matrix when we're doing it this method. All of these methods do the same thing. They all find X, Y, and Z. They're just different methods. We got to get used to seeing and using all of them separately. All right, do you need help writing the matrix, or do you think you got it? This one is going to be a 5. No, we're going to call it 4 by 5. But why is it going to be a 4 by 5?
Because there's an extra variable.
Good, there's an extra variable. There's an extra equation. 0, 1, 1, 1, 1, negative 1, 0, negative 1, 0, 1, 0, 0, 1, and 0, 1, 0, 1. My answers are 4, negative 4, 1, 1. So as Jake reminded me, it's a 4 by 5. Double, triple, quadruple check your equation, and then I want you to enter it in the calculator. And like I said, I like to always just like mess with the same first matrix. It's kind of your preference, but I like to always just deal with this one. All right. Once you make sure that your matrix is right, we're going to hit RREF, reduced row echelon form this time. So it should be all the way reduced for us. Oh, shoot. All right, this is what I get. Double check yours, see if you got the same thing. What questions do we have so far? From this, could you tell me what X is? What's Y? What's Z? And what's W? Is that so elementary? Is that why we all weren't answering? Is it too easy? Yeah, okay. It should feel that easy. I just want to make sure that you have it right because it would be embarrassing, I think, if it's that easy for us to not understand that. All right, I want to flip our paper over. I want to do C and D, same idea. C and D are going to be special cases though. So when you plug it in, you might get a funny answer. I'll be quiet. I want you to plug it in, write your augmented matrix, do your RREF. However, if you just did REF, just row echelon form, you would get the same answer as us. You'd still get a weird answer as well.
Are we done with B?
Would you say?
Are we done with B?
We're done with B. That's my answer. All right, once you've entered your augmented matrix in, go ahead and press RREF, and then we will see what happened.
How come there's not a one diagonal?
Great question. This is my special case. Did everybody get all zeros in the bottom row? That means that instead of having an equation that's z equals something, this instead says that 0 equals 0. Is that a true statement?
Yes.
Yeah, so what do we call this? Infinitely many, IMS, good. That means that anything I plug in should work. Infinitely many solutions, that means everything works. So if you get an entire bottom row of zeros, that's IMS. My other class was wondering what happened if like the first row was all zeros or the middle row was all zeros. I believe that the way the program works in the calculator is it goes like from the bottom up. So the only row that would be all zeros would always be the bottom. It should never be anywhere else. If it happens to be somewhere else, it will still be infinitely many solutions because that's what that one line would say. Go ahead and do the next one. I'm going to argue it should be the exact same thing. It's just a bigger matrix. So make sure that you check that matrix out. Make sure you get the same thing. Again, double, triple, quadruple check your work. Make sure you're plugging the right things in. Make sure you have the negatives in the right spot. I cannot stress that enough. I'm not even going to copy my whole answer down because I got some weird decimals, but I know that that whole bottom row is zeros. So I know that it is infinitely many solutions.
On a test, so as long as
That's fine.
there's not diagonal ones, it's infinitely many solutions.
As long as the bottom row is zeros, it's infinitely many solutions. And Ethan asked, could you like literally write this on a quiz? Sure. What I really want to see from it that you know that it's infinitely many are these zeros at the bottom. Okay. All right, we got to go back up. We've skipped Kramer's rule earlier. That's a no calculator thing. So I wanted to do kind of all of our calculator stuff. We're going to do Kramer's rule. And if we have time, we'll get one problem or two into 7.4. But if not, I'll be okay with that too. Okay. So Kramer's rule is a little bit different. What's going on here is in all of these methods, in the inverse method, in Kramer's rule, and Gauss-Jordan, and REF, and RREF, every single time we're finding X, Y, and Z, we're just finding these variables. Now, my other class kept being like, well, why can't we use substitution? Well, because we're in the matrix unit, and we're learning about matrices, not substitution. So substitution is a skill you can use if I don't give you any other direction. But if I say use any of these rules that we're talking about now, you must use these rules. So these are just different ways of solving, and we're doing them like kind of simple by hand and smaller levels that like you easily could do a substitution for this, but we're doing it small scale so that like when you would go do something bigger scale, it would make more sense. Okay, so Kramer's rule at the end of the day is that we're going to do some determinants. X is going to be the determinant of X divided by just our determinant of this equation. And Y is going to be the determinant of Y divided by just the determinant of this equation. So I need to tell you how to find D, how to find dx, and how to find dy. Once we find those three numbers, we just divide them and then we get X and we get Y. It's just a different way of looking at how to solve these. Okay. Now, we're not going to write a coefficient matrix. We're not going to write a solution matrix. We're not going to write an augmented matrix, but we're going to make 3 different matrices each time, thinking about these columns. My first column is going to be column A, and that's going to be all my X's. My next column is column B, which is all the coefficients of my Y's. And the last column, column C, is a column of all my solutions. So we need to label A, B, and C first so that when I talk about them in a second, we know what we're looking at. Okay. Big D is the determinant of columns A and B. So I'm essentially going to make a little 2x2 matrix with the coefficients of X and as the first column and the coefficients of Y as the second column. And we can find the determinant of that. Okay, so let's just pause. Let's go do that right now. So we're going to go find D. If D is A and B, I'm going to write my first column is A, 3, 2, and then my second column is B, -7, 1. Do you remember how to find the determinant? Cross. 3 times 1 minus was a big thing I saw on our quiz, on other people's quizzes, minus 2 times -7. 3 times 1 plus 14 is going to be 17. That's it. We're not doing the inverse of this little matrix. We're only finding the determinant. So D in this problem is 17. Are you okay with that? Yep. Okay. Now we're going to do dx. That means we're going to do the determinant of the 2 columns that are not X. So we are not using this column. We're not using A. Instead of using A, we're going to put C in A's spot. We're going to replace A with C, and we're going to keep B exactly where it was before. So now we're going to do the determinant of the column C, then B. We want it to be B, then C. Really the only problem I think that it becomes is I get the wrong sign. I think it's negative or positive, which I don't want. So we got to make sure it goes C and then B. If you do enough of these, though, you'll kind of find that trend. So dx, my first column is going to be 9, -6. My second column is -7, 1. Cross again. 9 times 1 minus -6 times -7. 9 minus 42, which I think is -33. Everybody good so far? Okay, the last one, dy, just like dx, it's going to be the determinant of the columns that are not Y. A is going to stay in its place, and since B is the one that leaves, B is going to be replaced by C. I like to think of C always does the replacing. It doesn't have its own spot. A, if you use A, it always goes first. B, if you use B, always goes second. C just kind of takes the spot of whatever's not there. And so it's going to be AC. So we're going to come down here and we're going to do that. A goes 3, then 2, and C goes 9, then -6. So I get 3 times -6 minus 9 times 2, -16. Oh no, -18 minus 18. Ooh, -36. All right, now I have all the numbers. Now I'm just gonna do the division. So x we said is gonna be dx divided by d. What was dx? Negative 33. And what's d? 17. Perfect. That's my x. Negative 33 over 17. And then y is going to be, what was dy? Good, divided by 17. Very good. Make those a little bit nicer. So the hardest part is finding those three little matrices, but you guys know how to do determinant. We're good at that. And you can divide two numbers. You're also good at that. Okay, why don't we try letter B? Same idea. I'm going to be quiet. I'm going to do it so you can watch me, but I'm going to be quiet and I want you to do it on your own. All right, check your D, check your DX, check your DY. Anybody have any questions with either of those, any of those? Okay, now we're gonna do dx over d, which is -9 over -1, which is 9. And we're gonna do dy over d, which is 26 over -1, which is -26. So what this means is whether I were to use substitution or inverse method or RREF or this new Kramer's rule, I would have gotten x equals 9 and y equals -26. Cool? All right. I want to get into a little bit of 7-4. I think we're a little bit of ahead of some of the other classes, and then this will give us more time tomorrow. We won't do a ton. We'll just do a little bit. Anybody have any questions yet? Okay, tonight your homework is 7-3, and we're going to go over it on Wednesday. Wednesday's the next time I see you, right? Okay. So I want to skip into 7-4. I want to skip the first one. We'll do that one tomorrow. I'm going to skip all of number 2 for right now. I just don't know if I want to do that, but we're going to jump down to number 3. Because number 3, we actually know how to do. We already learned this stuff. Good. We're doing some rational functions. Yep. Let's do letter C first. That's a nice, easy one to get us back into the swing of things. And then we'll do the other 2 next class. I know. It's never gone. Welcome to math class. I'm gonna make a little key on what we need to do right here, just because it's probably been a minute since you thought about rational functions. Ooh, that's not what I wanted to do at all.
How many tests and quizzes do we have?
You have one more quiz in chapter 7 and then chapter 7 test. And then we'll either do 1 or 2 quizzes and then a test for chapter 9. You're cute that you think you have a vote. We will see what we have time for. We're gonna call this little box graphing rational functions. You already learned this. You learned it in algebra 2. We did it in pre-cal already. We're just kind of reviewing it. Graphing rational functions. Okay. There are 4 things that I need to know in order to graph. Does anyone remember any of the things that I need to know to graph? What'd you say? X-intercept's good. I need to know my x-intercept. I need to know my y-intercept. Anything else I need to know? What'd you say, Bella? Asymptotes. We need a vertical asymptote and a horizontal asymptote. Look, you shook your head and you actually knew what was going on. Big heavy sigh. Okay. X-intercept we find by setting the numerator equal to 0. If I have 0 over anything, I will get 0. So if my numerator equals 0, then that will give me my x-intercepts. My y will equal, or in order to get my y-intercepts, we need to plug 0 in for all my x's. So we're going to plug 0 in for x's and then solve from there. Essentially, it's just looking at the constants, but this is mathematically what we do. Vertical asymptote. Do you remember how we find vertical asymptote? What did you say, Jake? Denominator. Good. Denominator equals 0. And then horizontal asymptotes, there were 3 rules, but the only one that's applicable on this page right now is if my exponents on top and bottom are equal to each other, then we make a fraction of their coefficients. So if the exponents are equal to each other, then we make a fraction of their coefficients. Can I tell you an embarrassing story really quick? I know that my handwriting is awful on this, and so I went and bought an Apple Pencil because I thought it would make it better. It does not work with my iPad. So I spent $100 on Apple Pencil. It does not work with my iPad. I'll go return it today. But I was like so excited. I was so proud of myself. I'm like, they're going to read everything so nicely. I plugged it in and it like didn't sync up. And I was like, I'm not an idiot. I should be able to do this. And I couldn't. So no, like this iPad just doesn't work with Apple Pencils. So
You got an old iPad?
it's an Air 2. I don't know. I don't know what that means. Oh, I don't know why mine doesn't work then. When I Googled it, it said it wasn't like a software issue, it was a hardware issue. So like physically the iPad doesn't work. So anyway, I'll have to figure that out later. Okay, what we're gonna do is we're gonna do letter C. We're gonna find those 4 things and we're gonna graph, and that's it for today. So let's do it. Let's do my vertical asymptote first. I think that's pretty easy. What do I do to find my vertical asymptote? Good. 8x plus 1 equals 0. Minus 1 divided by 8, x equals negative 1/8. Okay. I can do my horizontal asymptote while I'm here too. Remember, I look at my coefficient, or I look at my exponents, x to the first, x to the first. Do those match?
1.
Great. Not 1. We're going to make a fraction of their coefficients, which in this case is 7 over 8. So y is going to be 7 over 8. It is often 1, but this time we have to look at the coefficient, actually look at the coefficients and not just blindly write 1. Okay. Now let's do our x-intercept. X-intercept is which thing set equal to 0? Numerator. 7x minus 2 equals 0. Add 2 to both sides, divide by 7, x equals 2/7, good. And then my y-intercept, it says plug 0 in for x's. Okay, so y-intercept, instead of doing 7x minus 2, it's going to be 7 times 0 minus 2 over, instead of 8x minus 1 plus 1, plus 1. It's going to be 8 times 0. Those 7 times 0 and 8 times 0 cancel, so I get negative 2 over 1, which is negative 2. So y equals negative 2. Okay, I have 4 points. Remember, the intercepts go on the axes and the asymptotes are like vertical or horizontal lines that go through those points. So I'm going to start graphing those. My vertical asymptote goes through negative 1/8, so that's about here. We're just estimating. I don't have any points on this graph. I'm just estimating. My horizontal asymptote goes through 7/8. That's positive. I'm going to draw this way. My x-intercept is at positive 2/7, which is right about here. And my y-intercept is at negative 2, which is about here. Any questions on what I've graphed? Now what? Am I done? We're going to make our little kind of C curve. It approaches the asymptote on both sides, but it goes through my points. Is that it, or is there another one I need to take into account? On the opposite side. So if this is in the bottom right-hand side, I'm going to go to the top left-hand side, and I'm going to draw like a little C curve up there. Good. Okay. All right, that is it for today. So 7-3 homework, we didn't finish 7-4, so 7-3 homework is what to do next class.